Hello everyone, I am Dr. N.V. Sailaja, working as Senior Assistant Professor in VNR VJEC. Welcome to the lecture series on machine learning. In the earlier lecture, we have discussed on introduction to the machine learning. Now in this lecture, I am going to explain about one of the important classification algorithms, that is decision tree algorithm. So there are many popular classification algorithms to design the model. One of the most important one is the decision tree algorithm, and second one is the naive Bayes algorithm, and we have support vector mission, shortly called as SVM, and k nearest neighbor algorithm, and we have logistic algorithm. So these are the most commonly used machine learning algorithms to develop the models on any given data set. So in each of these algorithms, the structure of the model is different. In the decision tree algorithm, the model structure is in the form of a flowchart like tree, whereas in the naive Bayes, the algorithm has the statistical equations to predict the tuples, and in the SVM we have a kernel functions to predict the values, and in the KNN we use the distance metrics to determine the most nearest tuple so that the predictions can be done. So in the logistic also we use sigmoid function to classify the given tuples under one of the predefined categories. So out of all this, the decision tree is the most important one. Let us see the details of this decision tree. So as I said, decision tree is a flowchart like tree structure where the internal node represents the features and the branches represents the decision rule, and each leaf represents the outcome. So these are the root nodes in the decision tree, whereas the terminal node, also called as a leaf node, are the class labels. Class labels are called the predictions, or called as a predictions. So we will traverse from the root to the leaf of the tree to give the predictions about the given test sample. So this is how the tree structure looks like. So this is an example data set for making the predictions on whether to play tennis outside is yes or no. So we are given with a weather data, temperature, humidity, and wind values of the weather. So based on all these values, you have to predict whether a person can go and play the tennis outside, yes or no. So for this particular data set, the tree is constructed like this by having the outlook at the topmost level, that is called as a root node. So the test conducted at this particular root level is splitted into the three different branches: sunny, overcast, and rain. So the number of branches coming out of the node represents the number of distinct values at that particular attribute. So once the test on the outlook is conducted, then your data set is decomposed into three smaller subsets, like some subsets. So one subset will have the outlook as sunny, and the second subset will have the outlook as overcast, and the tuples having the outlook value as rain are taken into the third subset. So once this splitting is done, then again we further split this first subset by performing a test on some other attribute. So that is, here the test is conducted on the humidity attribute. So the humidity based on the humidity distinct values, the data set is further splitted into smaller subsets. So one branch will have the a data set which has the humidity value as high, and the other branch will have the data set with the humidity value as normal. So like this, on the right side also, we have conducted a test on the wind attribute with the two distinct values, so that two branches are generated. So one branch will have the subset of data containing wind as strong, and the other subset will contain the wind as a weak. So after this subset, if we get a node with the purity, that is called a pure node. So if all the samples belonging to the same class, then that node is called as a pure node. So in this case, all the data samples belonging to this humidity high data set are having the class as no, hence it is created as a label with a decision of no class. Similarly, the data set having the humidity as normal has all classes belonging to the S class, so it is converted as a leaf node by keeping the label as a S, by keeping label as S. Similarly, on the right side, so same kind of partitions were done based on the wind attribute. So here pure nodes were created so that they are treated as a labels by considering them as a leaf nodes with appropriate label names. So this is another example to predict whether a particular patient uh, suffers with a heart attack with a low risk or high risk. So here root is taken as a age attribute. Here the age of the person is tested based on the values less than 18, 18 to 30 and greater than 30. They are split into 3 smaller subsets. So people having less than 18 years are divided into first subset. Again, the test on the weight is conducted. If the patient weight is less than 60, then there is a low risk of having the heart attack. If it is greater than 60, then there is a high risk. So these are the leaf nodes giving the prediction values, nothing but the class labels. So in the middle branch, you have a age with the range 18 to 30. So here the direct prediction is given as low risk of having the heart attack. Now coming to the right sub branch, so here when age is greater than 30, then again a test is conducted on the another attribute, that is smoker, whether a person is smoker, yes or no. So it is further splitted. So here the pure nodes were created so that they are converted into a leaf nodes with an appropriate labeling, that is low risk and high risk. So this is the entire tree which will give the predictions about when a particular patient sample is given, then that sample must be categorized under either heart attack is having a low risk heart attack or high risk of heart attack. So this is the working principle of the decision tree algorithm. So initially, select the best attribute using the attribute selection measure. So the main objective of the entire decision tree algorithm is to select the best attributes to conduct a test at different levels of the tree construction. So first we have to select the root node. So that is the first step of the decision tree algorithm. So once the attribute is selected, then you have to break the data set into smaller subsets based on the number of distinct values of that selected attribute. Thirdly, start a tree building by repeating this process recursively until some of these 3 termination conditions are met. What is the first condition here? All the tuples belong to the same attribute value. Then that particular node is called as a pure node. So in the table, in the tree, we will have a pure node and impure node. So what is a pure and what is impure node means? If all the samples of a particular node belongs to a same class, then it is called as a pure. Otherwise, if there is a mixing of classes in the node, then it is called as a impure node. Then it is called as a impure node. So according to the termination condition 1, if we reach to the pure node, then that must be replaced as a leaf with labeling as a class name. So second termination conditions, there is no more remaining attributes to select and test at the node level. And third one is there are no more instances to further split the dataset into smaller subsets. So this is the algorithm that we use to construct the tree. And this is a basic structure of the algorithm. So where we start with the raw data, and this is going to be pre-processed here, pre-processed. And then it is splitted into training and testing set. This training set is used to build the decision tree algorithm model, where we select the best attribute by using a attribute selection measure, and then we will break the data set into a smaller subsets. This is an iterative process. It is keep on continued until one of the termination conditions mentioned in the algorithm are met. So once the construction is completed, tree construction is completed, then we have to evaluate the tree performance by using the test data. So we give some test sample here, and the model gives some predictions. That predicted value is compared against the actual value. So if they are differ, then it is called as a misclassification. If the actual and the predicted are same, then it is called as a correct classification. So, and we have some evaluation metrics, classification evaluation metrics to measure the accuracy of the model. So, the most popularly used are accuracy, score, precision, recall, and fourth we have F score also. So, these are the classification metrics used to measure the accuracy of the model. So, what is the terminology that we use frequently in the decision tree means root node, decision node, leaf nodes, subtree. So after testing, we will get one internal node. So from that node, the branches are explored further, which will create the subtree. So pruning is used to reduce the noise during the construction. So branch or a subtree, parent and child nodes. So this is the one data set which is given to predict whether a person buys computer, yes or no. So what are the features given in the data set here? Age of the customer is given, income of the customers, whether the customer is a student or not, credit rating of the customer is given, and based on all these features and or attributes, we have to predict whether a person buys the computer or yes or no. So using the attribute selection measure, we have to select the most appropriate attribute to test at the root level. So in this example, age is selected because it is identified as the best attribute. So in the data set, the age has three distinct values. One is the youth, and second is a middle aged, and third one is a senior citizen. So now for each of this distinct value, one separate branch is grown here, so which will lead to the splitting of the data set into a smaller subsets. So all the samples having age is equal youth will come into the first subset, and age with middle aged values will come into the samples will come into the second subset, and the samples with the age value senior will come into the third subset. So like this, one data set D is further divided into a subsets called D1, D2 and D3. Again, this D1 is further splitted into smaller subsets based on the test conducted at that particular level of the node. So why we have to split further means because there is a impurity in this particular subset. So some classes belonging to S, no, some classes belonging to no, and the remaining two samples are belonging to S class. Means there is a mixing of classes, nothing but it is a impure node. This is a impure node. So whenever there is a impurity in the data set, then that must be further splitted. This process continues until we get the pure node at the end. So this left sub branch has an impurity because some samples are belonging to no class and the other samples belonging to S class. So this need to be further splitted in the next level of the tree construction. Middle subset has all samples with the same class. That means it is a pure node. Whenever a pure node is obtained, then that should be replaced as a leaf node with the class label as a name of the leaf. So this is how we get the leaf nodes here. Coming to the right side, this subset has again mixing of classes. Some labels have S, some samples have S label, and the others have no labels. It's nothing but this is again impure. This need to be further splitted down in the next level of the tree construction. So after at the first level, we have the nodes, internal nodes, that is N1, N2 and N3. N2 is converted as a leaf node because it is a pure node. So this N1 is an impure. So again you have to perform a test on some other best attribute here. So student is selected. Now whether a person is student or not is tested here. If the customer is not a student, then we have to take it into this branch, and if the person is a student, then it should be taken into the right side. Similarly, right subtree. Here at the node N3, we conduct a test on the credit rating. So we have only two distinct values for credit rating. One is a fair and excellent in the data set, in the given data set, as we shown earlier, fair and excellent. So for these two separate branches are grown. Now we have to split it into two subsets. So again, in these subsets, all the classes are same. So it is a pure node. Then it should be converted into a leaf and labeled as a node. So right side also we got the pure node. So like this, we have constructed one decision tree for the BICE computer is equal to PCSR node dataset. So this is another example where we have A's in the form of a numerical values, that is less than or equal to 30, 31 to 40 and greater than 40. So based on the splits created by using a attribute selection algorithm, we are going to decompose the tables into data set into subsets, three different subsets. Again, those subsets are tested against another attribute, that is whether student or not, and they are further decomposed so that the tree is constructed. So in the entire process, we discussed that best attribute must be selected by using different attribute selection measures. So these are the heuristic measures used to find out which attribute will properly decompose the given data set into a smaller data sets. So we have three important measures here. One is a information gain ratio, and Gini index. Coming to the first one, information gain. So this is used by the algorithm called ID3, iterative dichotomizer, with these formulas. So information gain of D is equal to minus sigma I is equal to 1 to m pi log pi base 2, where pi is the probability that a class belongs to a class Ci. Probability that a particular sample belongs to a class Ci. So this indicates the average amount of information needed to identify the class label of the tuple in D. So once this is calculated, then we have to go for the second equation, that is info of D at A. At A means at some attribute. So this is equal to sigma j is equal to 1 to V mod dj by mod D into info of dj. So here mod dj by D is called as a weight assigned to that particular partition. Once we calculate the info of D for the given data set, then we have to divide this data set on some attributes and again calculate the expected information required to classify the tuple D based on the partitioning by attribute A. So finally, we calculate the gain of A by subtracting the first equation from the second equation, that is info of D minus info D at A. The attribute which has the highest gain value is selected as a best attribute for further splitting the dataset. So in our previous example, out of all the attributes, A has got the highest information gain value. Hence, this is selected as a root node to start the construction of the tree. The problem with the info gain, the first heuristic measure is, it is biased towards the attribute which has the highest number of distinct values. Suppose in your data set you have a customer ID, next age of the customer, occupation of the customer, and so on. Then this customer ID has the unique values for each record. Suppose if 100 records are there, then there will be 100 unique values here, right? So now if I apply information gain equations upon this particular CID, then obviously it will get the highest value when compared with the remaining attributes of this particular data set. Why? Because it has the unique number for each record. So those many number of splits are created which doesn't give any analysis over the data set. So to avoid this biasing towards the more number of unique values attribute, we use the gain ratio. So this gain ratio is implemented by the algorithm called C4.5, which is an improvement to ID3. So it avoids this biasing by normalizing with the another equation that is called split info D at A. So it is split info of D at A is given as minus sigma j is equal to 1 to V mod dj by mod D into log mod dj by mod D base 2. So here mod dj by mod D is called as a weight assigned to the partition of at the attribute A. So finally gain ratio is calculated as the gain previous info gain equation divided by split info of D at A. So we divide this gain A by using a split info of D at A so that the biasing problem is eliminated. The third heuristic measure used over here is a Gini index. So Gini means impurity. So this measure is going to create a decision tree with only 2 at most branches, hence it is called as a binary tree construction. So this algorithm is implemented by using a CART, classification and regression tree. So using this Gini index, we create the binary trees. Binary trees means at each level there could be more at most 2 branches. So Gini of D formula is 1 minus sigma I is equal to 1 to m pi square, where again pi is a probability that a particular tuple belongs to a class Ci. So this equation is going to explain how much impurity is there in the dataset D. Later, we divide the data set D by using one of the best attributes given in the data set so that we will get the impurity at each branch of the tree. That is calculated as Gini of D at some attribute A is equal to mod D1 by mod D Gini of D1 plus mod D2 by mod D Gini of D2. So again these mod D1 by D and mod D2 by D are called the weights assigned to the partitions. So this is the impurity at the first partition and this is the impurity at the second partition at the attribute A. So after that we have to calculate the reduction in the impurity by applying the formula delta Gini of A is equal to Gini of D minus Gini of D at A. So attribute that maximizes the reduction in the impurity is called as a best splitting attribute. So these are the measures that we use in our algorithms to select the best attribute at each node level in the tree construction. This is briefly about the decision tree algorithm. So each algorithm has its own pros and cons. Now coming to the decision tree, there are several advantages like easy to understand and interpret because we can easily understand the results generated by the decision tree by simply seeing the tree structure. Second advantage is handles both numeric and categorical data. So no matters what the data is there in your features. So it works for both numerical and categorical data for the features. Only the thing is target should be a categorical one so that we can apply the decision tree classification algorithm. It works both for continuous and categorical attributes. So requires minimal data preparations. So there is no need of normalization or encoding or handling the missing values in case of a decision tree algorithm because the tree itself handles the noise generated in the data set. Next one. So it captures nonlinear relationships between the features and the target variable without having any mathematical transformations. Next, feature importance measurement. See, at every level of the tree construction, we are focusing mainly on selecting the best attribute. That is nothing but feature importance. We are selecting only the features which are most appropriate for splitting the data set into smaller subsets. So works well with large data sets. Our decision tree algorithm is suited on smaller to larger data sets. Basis for powerful ensembling methods. So based on decision tree algorithms, only the advanced ensemble methods were created. So examples are random boost, random forest boosting and XGBoost algorithms. All these algorithms will have a basic foundation from decision tree algorithm. Coming to the disadvantages, the most important problem to be discussed here is decision trees are more prone to overfitting. This problem can be eliminated by using a pruning techniques. Again, in pruning, we have pre-pruning and post-pruning. We will discuss these topics in the next video. And we have another issue with the decision trees here, that is called unstable with small changes, data changes. Whenever a training data changes, then automatically the tree construction also changes. That is another problem. Bias towards dominant classes, as I discussed earlier, info gain is biased towards the attributes with a large number of distinct values. Computationally intensive for large data sets and hard to capture complex relationships. Thank you. We will meet in the next video with another topic which will describe another classification algorithm. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.